So in this class, we discuss collision-free protocols. There are two collision-free protocols. One is bitmap protocol and second one is binary countdown protocol. There are two collision-free protocols. One is bitmap protocol, second one binary countdown. Here first one, bitmap protocol. Here bitmap protocol is collision-free protocol. In bitmap protocol method, each contention period consists of exactly n slots. Here each contention period consists of exactly n slots. If any station has to send frame, then it transmits say, one bit in the respective slot. For example, here station 2. For example, here station 2 has a frame to send. So it transmits a one bit during the second slot here. Total 8 contentional slots. Okay, here 8 contentional slots. That is here n equal to 8. Suppose if any station has to transmit data, then it transmits bit 1 in the respective slot. Suppose here station 2. Here station 2 has to send the frame. So it transmits a bit 1 in the second slot. Okay. Bitmap protocol, it is a collision-free protocol. So here each contention period consists of n slots. In this example, contention period consists of 8 slots, 8 contentional slots. If any station has to send the frame, then it transmits a bit 1 in the respective slot. Suppose here in this example, station 2 has to send the frame. So it transmits bit 1 in the second slot. So this one is another example. Here stations 1, 4, 6, 7. These stations has to send the frame. So station 1 has to send the frame. So place bit 1 in the first slot. Here slot 1. Okay. Suppose station 0 has to send the frame. Place 1 in the this 0 slot. And next here station 4 has to send the frame. So place 1 in the slot 4. Station 6 has to send the frame. So place 1 in the this slot 6. Next station 7 has to send the frame. So place 1 in the this slot 7. Okay, so this is bitmap protocol. Second protocol is binary countdown protocol. So here binary countdown protocol is easy to overcome the overhead 1 bit per method. This binary countdown protocol is easy to overcome the overhead 1 bit for binary station. In binary countdown, binary station addresses are used. In binary countdown, binary station addresses are used. Here, a station wanting to use the channel broadcast its address as binary bit string starting with high order bit. Okay, suppose here 00001, okay, 0001, 1001, 1100, 1011. These are the binary addresses of 4 stations. Here 0001, 1001, 1100, 1011. These are the 4 binary addresses of the 4 different stations. Here these are the 4 binary addresses of the 4 different stations. 0001, 1001, 1100, 1011. So these binary addresses are OR together, result of OR operation here. These 4 binary addresses are OR together. Okay. Then depending upon the result of our operation, so which station move forward and which station gives up is decided. See, first we take the first bit, high order bit, MSB. So 0, here 1, here first bit is 1, and here first bit is 1. Okay, and now we perform OR operation. 0 or 1, 1, 1, 1, 1, 1, 1, 1. So the result of OR operation is here 1. Okay. Here, the most significant bits are together to decide which station is moved forward and which station dropped from the computation. See here, first bit is 0, and here first bit is 1, and here first bit is 1, and here first bit is 1. So the result of our operation 0 or 1, 1. 1, 1, 1, 1, 1, 1. So the result of our operation is 1. Okay. So whenever the first bit is 1, those stations are in the computation and remaining are out of computation, drops from the computation. See here, first bit is 0. So here station 1 is gives up. Okay, this station 1 gives up. That means station 1 withdraw from the computation. And these 3 stations will proceed. Station 2, and now we discuss these 3. 2, 3, 4. So here second bit is 0, and here second bit is 1, and here second bit is 0. Now once again we perform our operation 0 or 1, 1, 1 or 0, 1. The result of our operation is 1. Okay, that means whenever the bit is 1, whenever the second bit is 1, only that station is in the computation and remaining out of computation. See, limited contention protocol. Limited contention protocol. So here limited contention protocol is the combination of collision protocol and collision free protocol. Here limited contention protocol is combination of collision based protocol and collision free protocol. So collision based protocols are pure aloha, slotted aloha, CSMA/CD. Collision free protocols are bitmap protocol and binary countdown protocol. So your limited contention protocols are combination of aloha and bitmap protocol. So your limited contention protocol behave like aloha under light load, and limited contention protocol behave like bitmap or binary countdown under heavy load. Okay, so when the load is low, it behave like aloha. When the load is high, it behave like binary countdown or bitmap scheme. So this is about limited contention protocol. So the example of limited contention protocol is adaptive tree walk protocol. The example of limited contention protocol is adaptive tree walk protocol. So here adaptive tree walk protocol means partition the group of station and limit the contention for each slot. Here partition the group of stations into different slots and limit the contention for each slot. That means out of that group only one can try for each slot. Out of one group only one station can try for the slot. See here. Suppose here C star, E star, F star, H star. So the stations C, E, F, H was to transmit the data. Okay. Here the stations C, E, F, H are to transmit the data. 4 stations trying to occupy the single channel. Okay. 4 stations try to occupy the single channel. Okay. Then we determine first which station occupy the channel. Okay, so under slot 0 here, slot 0, under slot 0 all stations C, E, F, H has to transmit the data. So there is a conflict. Okay, under slot 0 here, 0 stations C, E, F, H has to transmit the data. So there is a conflict. Next, so here if there is a conflict, divide that group into 2 different slots. So here this one, first one is divided into 2 slots. So first slot consists of 0, 1, 3, 4, A, B, C, D. Okay, see here, first slot 0, the stations C, E, F, H are trying to send the data. So there is a conflict. So if there is a conflict, divide that group into 2 different slots. So here conflict. So divide this one into two different slots. So slot 1, 1, 3, 4, A, B, C, D. Okay, slot 1 here 1, 3, 4, A, B, C, D. That means we divide this tree into two different parts. Okay, so here slot 1 A, B, C, D. So here out of A, B, C, D, C only has to send the data. So there is no conflict. Okay, here there is no conflict. Only one station has to send the data. Here A, B, C, D, out of A, B, C, D, only C has to send the data. So C sends. There is no conflict here. Slot 1 C sends. Okay. Next slot 2. Here slot 2 E, F, G, H have to send data. Here out of E, F, G, H, only E, F, H have to send the data. Out of E, F, G, H. So here E star, F star, H star. So E, F, H have to send the data. So multiple stations. Here slot 2 E, F, H. So conflict. Okay. So now we divide this one into two different slots again. Okay. So here E, F one slot and H is one slot. Here E, F one slot and H is another slot. Okay. So here E, F two stations have to send the data. So there is a conflict. So once again we divide this one into two different parts. E is one slot and F is one slot. Here E is slot 4, E sends. Next F is slot 5, F sends. Okay. Next last one H. So H sends. There is no conflict, only one. So there is no conflict. So here this one is a adaptive tree walk protocol. If there is any conflict, divide that group into multiple slots. Okay. Out of that slot, only one station have to send the data. This is about adaptive tree walk protocol. So this adaptive tree walk protocol is limited contention protocol. That means partitioning the group of station and limits the contention for each slot. This is about collision-free protocols and limited contention protocol. Here collision-free protocols, there are two protocols, bitmap protocol and binary countdown, and limited contention protocol, only one limited contention protocol, that is adaptive tree walk protocol. This limited contention protocol is a combination of collision based protocol, that is Aloha, and collision free protocol, that is bitmap. So it behave like Aloha under light load and it behave like bitmap protocol under heavy load. That means when the stations are low, that means limited stations, it behave like Aloha. When the stations are high, that means multiple number of stations, then it behave like bitmap scheme. This is about collision free protocols and limited contention protocol.